A very good evening, dear students. This is the first video on this channel, and today we will be taking a topic of grade 11, that is isomerism. So let's begin. What is isomerism? The phenomenon in which different organic compounds having the same molecular formula but different physical or chemical properties are present. Such examples would be called as isomers, and the phenomenon is called as isomerism. Now, as you can see here, isomerism has broadly been classified into two categories. One is structural isomerism and the other one is stereoisomerism. Now, structural isomerism again has different types. The first one is chain isomerism. Then we have positional isomerism. We have functional isomerism. We have metamerism, and we have tautomerism. So let's take the first one. Under structural isomerism, that is your chain isomerism. Now, what do you mean by structural isomerism? Under structural isomerism, we will see under all these headings, we would see that the molecular formula for the different compounds would be the same, but their structural arrangements would be different, which means the arrangement of atoms around it would be different. In there, the position of the double bonds or the triple bonds may be different. The position of the functional groups may be different, or there would be different types of functional groups that would be present, but the overall molecular formula would remain the same. All these we would be able to see under structural isomerism. The first one is a chain isomerism. Now, what do you mean by chain isomerism? Under chain isomerism, the isomers, like I said before, will have the same molecular formula. Say, for example, we have to look into the isomers of butane. Now, if you talk about isomers of butane, we know that butane is how many carbons? Butane is 4 carbons, right? Now, chain isomerism would be exhibited by any example if it has more than 4 carbons or 4 carbons. So, either 4 carbons should be present, or you can have more than 4 carbons for any given compound to exhibit chain isomerism, right? So, if we talk about butane, how will we decide the molecular formula? How will we predict it? We know the general formula for alkane, that is CnH2n plus 2. Now, why is it an alkane? Because but represents 4 carbon, ane represents an alkane, which means that all the bonds are single bonds. So CnH2n plus 2, right? So carbon, when we are talking about but, how many carbons are there? C4H, 2 into 4 plus 2, right? So total how many hydrogens you have? C4H10. So this is the molecular formula for butane. Now let's see how many isomers are possible for butane. Okay, C4H10, right? Now, the first possible isomer for butane, 1, 2, 3, 4. There are 4 carbons. Now, let's satisfy the hydrogens. You will have CH3, 2 hydrogens, 2 hydrogens, and 3 hydrogens. Right, so I'll just write it, and then again I'll write the condensed formula, CH3, CH3, C and 3H, or you can write it in the condensed form as CH3, CH2, CH2 and CH3. Now all the 4 carbons are arranged in a straight chain, so what do we name it as? We name it as a butane, right? Now here in this particular structure, how many carbons are there? 1, 2, 3, 4. 4 carbons. How many hydrogens are there? 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens. So the molecular formula has been arranged in this particular way. So we can call it a structural formula. What is the other way of writing the same formula? That would be also the isomer. So this C4H10 can also be written as 3 carbons in a straight chain and 1 carbon here as a branch, right? Now if you satisfy the hydrogens, this carbon is having 1 bond, so you will have 3 hydrogens. The second carbon is having 3 bonds, so you will just have a single hydrogen. This carbon has 1 bond again, so you have 3 possibilities, so 3 hydrogen. This carbon is having 1 bond, so again 3 hydrogens, or I'll just write the structure again. You can even write it as CH3, CH, CH3 and CH3 in the branch. Now this is a straight chain, right? In the second carbon or in the second last carbon, this is only a 3 carbon system. So if you have the second carbon and from the second carbon you are able to see which group is this? This is a methyl group. So we have done this in nomenclature. If you are able to spot a methyl group in the second carbon or basically in the second last carbon, now because it's a 3-membered carbon, from any side you take, this carbon would be the second last carbon. So if there is a methyl group, then what do we call it? We can call it iso group. And how many carbons are there total? Total there are 4 carbons, so it would be isobutane. So which are the 2 isomers for butane? You have a normal butane and the other one is a isobutane. I hope it is clear. Let's take another example. We can even try the isomers of pentane. So you may know now how to write the formula C5H12. How did you get C5H12? Use the same general formula CnH2n plus 2, C5 because of the 5 carbon, H2 into 5 plus 2. So total you will get 5 carbons that you want to make your isomers with, and hydrogens would be 12, right? So let's start with the isomers now. So first one will be what? You can have all the 5 carbons in a straight chain, 1, 2, 3, 4 and 5. Satisfy the hydrogens, CH3, CH2, CH2, CH2 and a CH3, right? 1, 2, 3, 4, 5, and you have 5 carbons and 12 hydrogens. So just like your previous one, this would be your pentane. All the 5 carbons in a straight chain. See if we have got 12 hydrogens, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, 5 carbons, yes. So this is the first isomer for pentane. Which is the other way of writing, of arranging the 5 carbons. You can have 3 carbons. You can have 4 carbons in a straight chain, and in the second last, this would be the second last. If you are considering from here, this carbon would be the second last carbon, which on top of which I have put an asterisk. So this carbon can have a branch. Let's satisfy the hydrogens. This carbon is having 1 bond, so you can have 3 hydrogens. This carbon is having 2 bonds, so you can have 1 above, 1 below CH2. This carbon is having 3 bonds already, so there is just 1 possibility, 1 hydrogen. This carbon is having 1 bond, so it would be CH3 again. You can write it again in a condensed form, CH3, CH2, CH, CH3, and this carbon will have a branch which is CH3. Let's see if we have satisfied the numbers. 1, 2, 3, 4, 5. So we have 5 carbons. How about the hydrogens? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So C5H12. It's correct. Right? Now you see here in the second last carbon, which group do you have? You have a methyl group. Like I told you here in this case, what will be the name for this one? If the second last carbon has a methyl group, then what do we name it? We name it as iso. Iso what? How many carbons are there? 1, 2, 3, 4, 5. Total 5 carbons. So we call it as isopentane. I hope it is clear. So if the second last carbon has a methyl group, then what is the prefix that we use? We use the term iso, right? So this is the second isomer for pentane. We have one more, a last one which you can try. That would be the last isomer. So you will have 3 carbons in a straight chain. You can have 1 carbon above, 1 carbon below. Satisfy the hydrogens, CH3, CH3, CH3 and CH3. So if you consider this to be your straight chain, then in the second last carbon you have two methyl groups. This is a methyl group, this is a methyl group. So if there are two methyl groups in your second last carbon, then we use the prefix neo. What do we use the prefix as? We use the prefix as neo. Now two carbons are there, two methyl groups are there, so we will write neo. Neo what? Total how many carbons are there? 1, 2, 3, 4, 5. So this would be your neopentane. I hope it is clear. So these are the three isomers for pentane. So you have your normal pentane, then you have your isopentane, and then you have your neopentane. Okay, let's see the next isomerism, that is position isomerism. So under position isomerism, this is again a type of structural isomerism, right? So the isomers will differ with respect to the position of multiple bonds. That is one type. Your multiple bonds position can be varying, or the position of the substituents can be varying, or the position of the functional groups can be varying, right? Let us look at few examples. One simple one, C4H8. What is C4H8? C4H8 is a butene. It's an alkene, right? With 4 carbons and a double bonded system. But indicates 4 carbon, ene indicates that it's a double bonded system. It's a multiple bonded system. So when you talk about multiple bonds, children, it can be a double bond or it can be a triple bond, right? Okay, now let's try to draw the structure. So C4H8. So 4 carbons, one possibility is in a straight chain, and you put your double bond in the center. Let's satisfy the hydrogens. So you will have 3 hydrogens here because carbon is having only one bond. This carbon is having 3 bonds, so there is one possibility, so 1 hydrogen done. This carbon again 3 bonds, so 1 possibility, 1 hydrogen is done. This carbon is having 1 bond, 3 possibilities, 3 bonds left, so 3 hydrogens. So what will be the name? How will you name it now? 1, 2, 3 and 4, right? Now this straight chain is having 4 carbons. So 4 carbons, so it's definitely a but. Now what do we see? What else do we have? We have a double bonded system. Now this double bonded system is present where? It is present between carbon number 2 and 3. You would have already done under IUPAC nomenclature. When we have a double bonded system, or if we have a triple bonded system, that would be present between 2 carbons. Now which number will we take? We'll take the number which is a lower number, right? So out of 2 and 3, which one goes for the naming? We'll take number 2. So but 2 and what else? Ene. So but indicates that there are 4 carbons. Number 2 here indicates that the position of the double bond is between 2 and 3, and ene of course indicates that there is a double bonded system which is present. So this is the name, that is butene, and this is your first isomer for C4H8. Is there any other way? What are positional isomers? Isomers will differ with respect to the position of the multiple bonds, right? So here the position is between 2 and 3. Can we have any other position? Will that be the next isomer? So again, you put 4 carbons in a straight chain. That's done. Here we had drawn a double bond between carbon number 2 and 3. Is there any other possibility? You can draw a double bond here, right? Or you can put it here also, children. It's one and the same thing. So here, if you are putting the double bond, your number will start from here. Correct? 1, 2, 3 and 4. Now let's satisfy the hydrogens quickly. This carbon is having 1 bond, so you will have CH3. This carbon will have 2 bonds, so you'll have CH2. This carbon is having 3 bonds, so just a single H. This carbon is having 2 bonds, so CH2, right? I hope it is clear. How will you name it? 4 carbons, so but. Done. 4 carbons, so bute. Can you all also try naming it? Now here the double bond is between 1 and 2. So double bond is between 1 and 2. So which number will we take? Again the number which is lower. So bute 1-ene. Right? These are the two isomers possible for your C4H8. So if you count the number of carbons, number of hydrogens, carbons would be 4, number of hydrogens are 8, and the formula here is also C4H8, but the name and the structure is different. This is bute 1-ene, this is bute 2-ene, right? Similarly, you can try for C4H6. Right? This is a triple bonded system. You can try it as homework and we can check it in the next video if what you have done is correct or not. Okay, maybe we can try one more example where the positions are different. How about your xylene, right? If you talk about your xylenes. So what is the formula for xylene? Basically, you would have done this already in your nomenclature. If you have a ring and a if you have a benzene ring and if you have 2 methyl groups, then this arrangement or this formula is known as xylene, right? Now when the 2 methyl groups are in the adjacent positions, they are next to each other, then what is the name? We call such examples or such compounds as ortho, right? This is like the ortho naming. Now on the other hand, if you take the same benzene ring but one methyl group, we are keeping it constant here. So this methyl group, instead of putting it in the adjacent position, I am putting it in this alternate position. So there is a gap of 1 carbon here which is left vacant now. So you have CH3, CH3 here. Now this is not ortho. If such an arrangement is seen, you will call it meta, right? There is one more possibility of drawing it. You have your benzene ring, keep this methyl group fixed and let's use the opposite position, this CH3. So you have skipped 2 carbons here, right? So if you see an arrangement like this, we call it a para group. So we can call it basically ortho position, meta position, para positions. So what are these? These are xylenes. So this you can write it in short as ortho xylene. Meta can be written as M-xylene. Para can be written as P-xylene, right? So all these are what? Examples of xylene. So xylene's formula remains the same. What is the formula for xylene? What's the formula for benzene, children? Benzene is C6H6, right? Now from C6H6, what will happen? 2 positions have been substituted, right? So that will become C6H4 because 2 carbons are substituted, and in that 2 carbons, what do you have? You have your CH3. How many CH3s we have? We have 2 CH3. So what is the formula for the xylene? C6H4CH3 whole twice. I have just shown you from xylene, from benzene, how will you get a xylene? So orthoxylene, metaxylene, paraxylene. So all the 3 will have what? Same. The molecular formula would be the same, but what are different? Their structures are different. Structures are different in which way? The position of the groups are different. I hope it is clear till here. You can take another type now, which is your functional isomerism. So this is the 3rd type under your structural isomerism. Now functional isomerism, how will you define it? Isomers which differ with respect to the nature of the functional groups, right, belong to this category. Let's see the examples. Say you have C2H6O. This is your formula, C2H6O. So your example has 2 carbons, 6 hydrogens and 1 oxygen, Fine. Now you would have studied under nomenclature what are the different types of functional groups that we have. So one can, if there is a O, let's see, you can have two carbons, right? And you have a single oxygen. I'm just writing it. We'll work it out. How is it? Now, how many hydrogens are there? So carbons we have done. Two carbons done. How many hydrogens? 6 hydrogens. So this carbon is anyways having one bond. So there is a possibility this carbon can have 3 more bonds. 3 hydrogens are exhausted. This carbon is having 2 bonds as of now. There is a possibility of it having 2 more bonds. So we have put 2 hydrogens. Now 5 hydrogens are done. There is still 1 hydrogen left. And we can write 1H here. So which group does this become? This becomes your functional group alcohol, right? So CH3, CH2, OH. How many carbons are there? There are 2 carbons. So what will be the word root? It would be ethane. And because it's an alcohol, what would be the suffix? The suffix used for alcohol is all. So ethane, all. Right, so what will be the name of this one? This name of this compound is ethanol. C2H6O, right? Any other way, any other possibility? So the functional group that we used here was alcohol. So now what is our intention? So this is the first isomer. Now we need to have another isomer with a different functional group, but the formula should remain the same. So C2H6 should be there, but the functional group would be a different one. So what will it be? So you can have oxygen, say, in the center, and if you have CH3 and a CH3, right? How about this one? ROR, or you can have ROR, or you would have studied ROR dash when the alkyl groups are same, when the alkyl groups are different. CH3O, CH3, how will you name it? Since both the carbons are equal in number, so one will go with the oxygen, so it would be methoxy, the one which goes with the oxygen, methoxy, one carbon, and one which remains, or one which is without the oxygen, so it would be methoxymethane, which is your ether. Clear? So if you see here also you have C2H6, and which is the functional group here? You have an ether. So the first functional group that you had was with an alcohol. The second isomer that you have is with an ether. But the molecular formula in both the cases remains the same. But if you see, the functional groups have been changed. So this was all about functional isomerism. In the next video, we'll take the isomers which are remaining. Thank you.